Welcome back to our magic tutorials for chemistry. So today we'll discuss about group number 17 elements, its properties. So group number 17 elements, they are fluorine, chlorine, bromine, iodine, astatine. Correct. I have written the noble gas electronic configuration here. So as we are moving down the group, the number of shells are added. Correct. The elements of group number 17, they are called as halogens. They are called as halogens. Why they are called as halogens? Halo means what? Salt. Gens means producers. So group number 17 elements, they are called as halogens. They are salt producers. The first property we are going to discuss is the atomic radius. Okay. So atomic radius, we are talking in a group. So atomic radius down the group, what happens? Down the group, it goes on increasing. Down the group, atomic radius, atomic size, atomic volume increases. Why it is increasing? Because the atomic number is increasing. Correct? Atomic number is increasing, and you can see the shells are also increasing. So if the shells are increasing, then atomic radius, atomic volume, atomic size will also increase. We will see the next property, that is ionization enthalpy. So ionization enthalpy means what? Energy needed to remove an electron. Okay. So down the group, what is happening? The size is increasing. If the size is increasing, that means the nuclear force of attraction to the outermost electron will be less. Correct? The outermost electron is loosely bound to the nucleus. Force of attraction is less, so it is loosely bound to the nucleus. So you can easily remove it. The outermost electron can be easily removed. Therefore, down the group, the ionization enthalpy decreases. Let's discuss the third property, electron gain enthalpy. I'll write it as EGE, electron gain enthalpy. Okay. So, electron gain enthalpy means what? The energy required to add an electron. And we know that halogens, they will gain an electron. So, we will compare for fluorine and chlorine. Fluorine is having less electron gain enthalpy than chlorine. Okay, fluorine is having less EGE value than chlorine. So, what is the reason for this? And it is having less negative EGE value also. So why it is negative, we will see that. So halogens, what they are doing? They are gaining an electron to complete the octet. We know fluorine, what is the electronic configuration? 9 is the atomic number. So 2, 7. Chlorine, 17 is the atomic number. 2, 8, 7. So the outermost shell, it has 7 electrons. So it gains 1 electron to complete the octet. So gaining an electron, the atoms will become what? Negative ions. So if it gains 1 electron, fluorine will become F minus and Cl minus. 1 we are not writing, I just wrote to explain it. Correct? So it gets a negative sign. Okay. Moreover, when an electron is added, suppose this is a nucleus, shells are there. So when an electron is added, what is happening? There will be a force of attraction by the nucleus. Correct? Something force of attraction or some formation. So that formation or some force of attraction, if it happens, more heat will be released. If heat is released, what it is? Exothermic reaction. And if it is exothermic, means it will have a negative sign. Correct? So that is the reason it is having a negative sign. First reason is it gains electron, becomes negatively charged, and the second reason is attraction happens between the nucleus and the incoming electron. Okay, therefore it is exothermic. Something is formed, a bond is formed, or we can say there is an attraction by the nucleus for the outermost electron. So it is exothermic, negative, less negative. Now let's see, fluorine is having less negative EGE than chlorine. Now down the group we know that if we compare for fluorine and chlorine, the size of fluorine is less compared to chlorine. Chlorine, the size is more, and it is having how many shells? 1, 2, 3. Nucleus. Fine. 3 shells chlorine is having. Fluorine, it is having how many shells? It is having 2 shells. 2, 7. 2 electron and 7 electrons. Here it is having 2 electron, 8 electron, 7 electron. So what will fluorine do, chlorine do? It will gain 1 electron. Okay. Now if it gains 1 electron, fluorine, the size is very, very small. So the nuclear force of attraction for the incoming electron will be more, FOA, that is force of attraction will be more, correct, because the size is very small. So if the size is small, the force of attraction is more. So the incoming electron can be holded by the nucleus very easily. So you need to provide less energy. You are adding 1 electron. Correct. So less EGE, electron gain enthalpy, is less here. Easily it will be attracted by the nucleus. Okay. Now in case of Cl, there are 3 shells. The incoming electron will come to the last shell, and therefore the 7 electron, now it will become 8 electrons. Octet will be complete, stable configuration. Okay. Now it becomes 8 electrons. See for the next shell. And this shell, it is called as the penultimate shell. So in the penultimate, that is second last, penultimate shell, 8 electrons are there. There also the octet is full. That orbit, it is full. That shell is full. So 8 and 8 electrons, what will happen? There will be electronic repulsion. Correct? We call it as inter-electronic repulsion. Why it is inter? Because it is between the 2 shells. Electronic repulsion, repulsion between the electrons. Right? So if the electrons are repelling, but you want to add 1 electron also. You want to add, but it is coming back, repelled, bouncing back, right? So more energy will be needed to add that electron because it is coming back, repulsion is happening. So EGE value for chlorine is more than fluorine. In case of fluorine, it is strongly attracted by the nucleus, less energy needed. But in case of chlorine, more energy is needed to add that electron because of inter-electronic repulsions by the penultimate shell electrons. Correct? So that is the reason fluorine is having less negative electron gain enthalpy value than chlorine. Hope this property is clear to you. See the next property. Enthalpy of dissociation. Energy needed to dissociate. We know they all are diatomic molecules. Halogens exist as diatomic molecules, that is F2, Cl2, I2, Br2, correct? So enthalpy of dissociation. Now check, just we will check the trend first, then I will explain this. So as we move down the group, what is happening? The size is going on increasing. This is for fluorine, suppose this is for iodine, I2. Okay. So as we move down the group, the size is increasing. Now dissociation. The bond length here it is more because the size is more. If the bond length is more, it is easy to break the bond. Correct? That means the bond between I and I, it is easy to break. Right? Because the size is big, bond length is more. So easily it can be dissociated. So less energy is required to break the bond between I and I, right? Okay. For fluorine, more energy is required. Why? Because the bond length will be very small. Bond length is very small, correct? And it will be difficult to break the bond. More energy is required to break the bond. So the order goes like fluorine, chlorine, bromine, iodine. Fluorine will need the most enthalpy of dissociation. For fluorine will be maximum. Cl2, then Br2, then I2. So I have written here the order. Chlorine will have more enthalpy of dissociation. It will be highest than Br, than I. Correct. Now fluorine I have not written here. So it is found that fluorine, the enthalpy of dissociation value, it is between Br and I. Now what is the reason for this is, in fluorine we know 7 electrons are there. Correct? Valence shell, 7 electrons are there. So what is happening? There is a lone pair of electron also. Size of fluorine is also small. Electron density is more. So what will happen? Repulsion will take place. They will be repelling from each other. Correct? Both the atoms, they will be repelling from each other because there is a lone electron. Moreover, the size is small. Electron density is more. So they will be repelling. So if they are repelling, what happens? They get the size almost similar to Br, in between Br and I. Okay, so because of this, for fluorine, the enthalpy of dissociation, it is less than bromine, Br2. Why? Because of the electronic repulsions. Size is small, electron density is more, electronic repulsions take place. Correct? So because of this reason, fluorine, the enthalpy of dissociation, it is between Br and I. So this is the order of enthalpy of dissociation.